Hi students, so today we are going to talk about the transient circuits in which we have the storing element as the capacitor here. So in this circuit we have to find the expression for the V naught of t for time greater than 0 when the switch opens at t equal to 0. Okay, so that is the scenario, and here we have to analyze the circuit. So in all these transients, again we have two instances, and the first instance here is when time is less than 0, or the time when the switch is in its normal condition. So when time is less than 0, how would the circuit behave? So the circuit will behave like, here this is the resistor, we have the voltage source here, and similarly here we have a capacitor as a energy storing device or energy storing element. So in steady state, when the switch is in original condition, so the capacitor will behave as an open circuit here. So when it will behave as an open circuit, the circuit we have will be like here, and here it is the open circuit here. And similarly, when here the switch is in closed condition, this one will be here, and also the resistor and a second voltage source here. Okay, that is here, and at the end we have the last resistor here as well. So the circuit here we will have like this one. This is our circuit now. So the value of resistance here is 1, here this is 2, the voltage here is 12 volts, here the resistance is 2 ohm, similarly the voltage here is 8 volts, this is 2 ohm, and the voltage or V naught of t is here. Okay, so now we have this circuit, and we have to analyze it for the V naught of t when time is less than 0. Okay, so that is the scenario. Similarly, in order to analyze it some more and giving a very clear overview of this circuit, let me again draw it with a very simplified sketch. So this is the resistor and the voltage here. Similarly, we can see that this 2 ohm resistor, 1 ohm resistor, and 12 volt source, these three are in series configuration. So 2 plus 1 will be 3 here, and this 3 can be written like a single resistor here and a voltage source here, and at the end we have this resistor. Okay, so we have this configuration here. This is plus minus V naught of t, this is the 2 ohm, this is again 2 ohm, plus minus 8 volts, this is the plus minus 12 volts, and 3 ohm. Okay, so that is the circuit, and what we have to do, we have to calculate the value of V naught of t, which is across each and every branch which are connected in parallel here. Okay, so we have to find out the value of V naught of t. Here we can apply many methods, many techniques, but one I am considering the very feasible one here is basically the node voltage method. Okay, so in considering the node voltage method here, let me consider this one is the node 1, while this is the node 2. Okay, so let me call this voltage as V naught and taking it as a ground here. Okay, so what will happen, there are basically now 3 currents which are passing through it. So the first current is here, let me call it I1, the second current is here which is passing through this one, let me call it I2, and the third one here which is passing through this 2 ohm resistor, and let me call it I3. Okay, so according to this configuration here, what we have, let me apply KCL here. So according to the KCL, I1 plus I2 and plus I3. Okay, so the summation of these three currents is equal to 0. Okay, so the summation of I1, I2 and I3 is 0, and that is due to the KCL here. So now analyzing this circuit here and writing the expression for everyone here. So I1 here is basically the V0 minus 12 divided by 3. So V0 minus 12 divided by 3. Similarly, what is the value of this I2? That is V0 minus 0 minus 8 divided by 2. So that would be V0 minus 8 divided by 2, and the value of I3 here is V0 minus 0 divided by 2. So that would be V0 divided by 2, and the summation of all of these three is equal to 0. Okay, so now this is a single equation in which we have to find out the value of V0. So in order to find the value of V0, let me take the LCM of this. So by taking the LCM here, what would happen? The LCM here will be 6. Okay, so now here multiplying this term with 6, what will happen? 2 will be multiplied with all the numerator here, so that would become 2V0 minus 24 plus this 3V0 minus 24, because when V0 minus 8 divided by 2 will be multiplied by with 6, what will happen? 3 will be multiplied with this V0 minus 8, and similarly in the last term the V0 by 2 will be multiplied by 6, and here I will get 3V0, and that is equal to 0. Okay, so now this is my equation here. So let me go down here. So now solving it for the 2V0, solving it for the V0, let me simplify it. So this V0 term, this and this, these three will be added together, and I will get 8V0, and similarly minus 24 and minus 24, that is minus 48 divided by 6 equal to 0. So multiplying both sides by 6, what I will get? I will get this expression. So here again 8V0 is equal to the 48, or the value of V0 here will be 6 volt. Okay, so this V0 is basically the V0 of t, and this is for t less than 0. So this is the expression for V0 of t when t is less than 0. So this is the initial condition which I have to find out, and similarly in this initial condition we can very easily see that V0 of 0 will also be equal to 6, because in transients, changing the condition of the switch, the initial condition doesn't change rapidly. Okay, so that is the condition, and that is basically the expression here. Okay, so now let me extend our circuit, and now let me try it for the instance when this circuit or this switch changes its position. So when it will change its position, this circuit or this branch will be cut off, because now this switch is in open condition, and changing it will give me this condition which will be for time greater than 0. So when time is greater than 0, what will happen here? We can very easily see that the capacitor will remain here while this branch will be removed. So when this branch will be removed, what will happen here? Here it will be the resistor, this one here, the capacitor will be here. Okay, there is another resistor where he will be here, while the branch here will be terminated due to the non-availability of a short switch here, which is now in open condition, and similarly at the end we have this resistor as well. Okay, so that is the circuit now in which what we have to find the expression for V naught of t. So now what is the value of this? So the value of this is basically the 12 volts, this is 3 ohm, and similarly this is basically the, let me take a look here, this is 1 ohm while this one is 2 ohm, this one is also 2 ohm. So let me remove it. So this is now 1 ohm, this is 2 ohm, sorry, this is again 2 ohm, and here this capacitance is basically the 2 farad. Okay, so that is now 2 farad. Now let me look at it, and what we have to do, we have to find the value of V naught of t. So let me write the value of the voltage here as V of x, and again applying the node voltage method here, let me assume the first current here as this one, let me call it I1, the second current will be here and that is I2, while the third current is here which is flowing through this and will come here, so that is I3. So now according to the KCL, the summation of I1, I2 and I3, okay, so the summation of these three is equal to 0. Okay, so now let me analyze them and find the values which I have to find now. So here what will happen, the value of I1 will be Vx minus 12 divided by 1. So Vx minus 12 divided by 1. Similarly, what is the value of I of 2? The value of I of 2 is here, which is passing through this capacitor, so let me call it I of C. Okay, similarly the last value which is flowing through these two resistors will be Vx minus 0 divided by 4, so that would be Vx divided by 4, and adding them together that will be equal to 0. Okay, as I have written it with the blue color as well, let me remove it and write it, sorry, again this color, so that would be Vx divided by 4. Okay, so now let me simplify it to find the value of I of C. So for simplifying it, multiplying both sides by 4. Okay, so when I will multiply both sides by 4, what I will get here, I will get 4Vx minus 48 plus 4IC plus Vx equal to 0. Okay, so that is the equation here, and in this equation let me write the values, or adding this Vx terms together, what I will get, 5Vx minus 48 plus 4IC, that is equal to 0. Okay, so now we have this term, and in this term we can very easily see that what is the value of Vx and how to relate the value of V naught of t here. So after finding the value of Vx here, we can very easily see that as the two resistors are same here, so here V naught of t will be equal to the Vx divided by 2. Okay, so let me call it equation A, and now let me move towards my question here, and here I can very easily see that 5Vx plus 4IC that is equal to the 48. Okay, so I can very easily see here that here the value, this Vx is basically the value of the voltage across the capacitor. So let me call it V of C. So calling it the Vc of t. So what I will get, I get Vc of t, and calling the current here as the Ic of t, this will become 48. Okay, so that is the equation here. Or simply now rearranging it, what I will get, I will get 4 Ic of t plus 5 Vc of t equal to the 48. Okay, or dividing both sides by this 4, this Ic of t plus 5 by 4 Vc of t equal to the 12. Okay, so now this is my equation, and let me call it equation B. Okay, so in this equation B, I can very easily see that for the capacitor, the value of Ic of t is always equal to the C dVct divided by dt. Okay, so in this scenario, writing the equations like in this equation, so what will happen here, writing here the value of C will be 2, because the capacitor here is of 2 farad. So here 2 dVct divided by dt plus 5 by 4 Vct equal to 12. Okay, or dividing both sides by 2, now again what will happen, I will get dVct divided by dt plus 5 by 8 Vct, and here it will become 6, and let me call it equation C. So now this is equation C, which is basically the first order non-homogeneous equation, and we have to find the solution of this equation as well. So as we already know, the solution of this equation will be like Vct will be equal to the k1 plus k2 exponential of minus t over tau. Okay, so that is the general term of our solution, in which we have to find the value of tau as well. But as we don't know the value of tau, but we have this equation, so from this equation we can very easily see that the value of this tau will be equal to the reciprocal of the coefficient, which is with the non-derivative term. Okay, so now writing here, this tau will be 1 over 5 by 8, which will be equal to, tau will be equal to the 8 by 5. Okay, so now writing it in this equation, what will happen, I will get Vc of t equal to the k1 plus k2 exponential of minus 5 by 8 t. Okay, so this is basically the equation in which I want to find out the value of k1 and k2. In order to find the value of k1, what we have to do, we have to use this k1 and put it in equation C. So when I will put this k1 inside this equation, what will happen, this term will become 0, while 5 by 8 k1 will be equal to 6. I will get this term here, so writing it here as well, what I will get, 5 by 8 k1 equal to 6, or the value of k1 is 6 multiplied by 8 by 5. Okay, so now we have this term here, which is now 48 by 5. Okay, so now writing it here, what I will get, VCT is equal to 48 by 5 is almost equal to 9.6. So writing this equation here, what I will get, 9.6 plus K2 exponential of minus 5 by 8t. So let me call it equation D. Okay, so now in this equation, what we have to do, we have to find the value of K2 here as well. So in order to find the value of K2 here, let me put t equal to 0. So putting t equal to 0, what I will get, VC 0 and 9.6 plus K2, because the exponential of 0 is 1, so I will get here this term. So now here, in order to find the value of K2, what we have to do, we have to put the value of VC0. Where to find the value of this VC0? So let us recall that in solving this problem here, we have earlier found the value of VC0, and that is basically 6. But wait, what is this V naught of 0? That is not VC of 0, but that is the value of this V naught. So what to do here? We don't have any V naught here, but we have this VC of 0, and these are now here. So now in order to proceed here, what we have to do, we have to convert this equation into the V naught of t, and that is the same scenario which we have already modeled here. Okay, so that is the scenarios. Let me proceed here in such a way that to make this equation as that of V naught of t. So in order to make it or convert it into V naught of t, what we have to do, we can recall that the value of V naught of t is equal to the VCT divided by 2. Okay, so now writing the values here, what will happen, 9.6 divided by 2 is 4.8 plus K2 by 2 exponential of minus 5 by 8 of t. Okay, so let me call it equation D. Okay, so now writing t equal to 0 here. So when I will write t equal to 0, that would become V naught of 0, 4.8 plus K2 by 2. So that is the scenario, and we have to find the values here. So in order to finding the values here, we have to put the value of V naught of 0, and that is the same value which we have earlier found out, and that is now 6. So now writing here, 6 equal to 4.8 plus K2 by 2. So from here, K2 by 2 is equal to the 1.2, or K2 is 2.4 here. Okay, so that is the value of K2, and let me put it in equation A. What I will get the value of V naught of t equal to the 4.8 plus this K2 is 2.4. 2.4 divided by 2 is 1.2. So I will get 1.2 here, and that would become exponential of minus 5 by 8 t for time greater than 0. Okay, so that is the equation we had to find out. So that is the equation for time greater than 0, or the general expression for our circuit which is modeled here. So in this circuit, we can now put any value in our equation which we have found out, and this equation will give us the value of voltage V naught of t at any instance which we want to consider. So that's it for today, in which we have solved our circuit, which is basically composed of a capacitor as a energy storing element and a normally closed switch. So we have analyzed it and we have seen different scenarios which can occur in these type of questions. So I think it is clear now, and I will see you with some more questions. Till then, take care of yourself. Thank you so much.